anybody get a chance to see any of the videos that I mean, that's fine, because I'm going to reference them so you can go watch them at any point in time. I'm kind of curious if they're useful or not, because, like, I forgot. Honestly, for us or something. And people not even using it. So, that's fine. Well, did anybody watch any of the videos? No. Okay. Sorry? Yeah, I try to pick those that I thought were a nice balance of not too long and useful. And I try not to use the same person all the time because I want to take a variety. There's tons and tons of videos on this stuff. It's not like there's anything magical about this. But all right. So we're going to start off with this, at this point, ancient case of a company called Capital One. Has anybody ever heard of Capital One? What do they do? Credit cards? Right. They issue credit cards. They're here in Canada. They're in the US. They're a big company. I actually know people who work for them and do financial management for them. So they're big enough that they had more than 100 million credit applications, and those credit applications actually were stolen. Somebody exfiltrated the data from AWS. S3, actually, I think it was. Oh, I didn't catch that. There's this weird thing where if I put the slide and mark down and I don't put a blank line between the title here and the numbers, it collapses it all. And I usually catch it, but I missed it. All right. So somebody basically just misconfigured their reverse proxy server that was run, an EC2 instance they were running, and so then there was a server-side reference something. It's a web attack, basically. An SSR attack is where someone has spoofing a session. I think I talked about sessions. Right? Yeah. Right. So the session is usually kept in some sort of a key value store. And if somebody can figure out how to spoof, like they can steal a token, then they can actually impersonate you. And that is one of the ways that unscrupulous people use to break into your cloud-based app, your cloud service, your website, whatever it is. And then that allowed them to get into an EC2 instance that was running their metadata service, which meant they could get IAM credentials, and we've talked about IAM credentials before, so basically they were able to pretend they were somebody else, somebody with actual authority to do something. And then that particular IAM role that they were able to hack had access to every one of their S3 buckets. Now this is really interesting because how many of you have actually used an AI to do any kind of programming with? A couple hands go up, right, okay. So no big surprise there. I fight this all of the time. I was literally fighting this morning with Claude, where no matter how many times I say least privilege, it ignores it. Why does it ignore it? Anybody know? Why can you tell an AI to do something and then it just goes and not does it? I mean, your parents probably ask the same question about you. Have you ever gone and done something your parents told you not to do? Or not done something your parents told you to do? In the case of Claude, in the case of ChatGPT or Gemini or any of these AI agents, the reason this is happening is because it's what they were trained to do. They're all trained on everything they could scrape off of GitHub, everything they could scrape off of Stack Overflow, everything they can scrape off of Reddit. And if you've read GitHub, Stack Overflow, or Reddit, you know that these are nothing but the top-notch, the most high-quality code sources that one could imagine, right? Has anybody here ever gone to Reddit? What would you describe Reddit as? I don't know. Okay, maybe it's a great source then. Based on a notebook, I would say that it's probably a really good source, but and I've seen enough Reddit flame wars. I actually avoid Reddit. Because to me, I look at Reddit and I say, these are a bunch of people who are all very deeply opinionated and not very interested in learning things, just in defending a position. Not everybody's like that, but there's enough of that that makes it difficult to use. Stack Overflow, on the other hand, seems to mostly be like people giving answers to things they don't really understand. So the quality isn't great. GitHub, I think actually some of the better code might come from GitHub, but equally some of the worst code comes from GitHub. And one of the patterns that I've actually seen, it's so bad that I have an entire story around it. There's this product that Microsoft has that a few people use called SQL Server. And SQL Server is literally an entire division with multiple buildings at Microsoft because it is a huge, huge project. It is a significant source of revenue because it's something that they've done for a very long time and they've done well. And so years ago, more years ago than I'm going to admit at the moment, years ago, I literally set up a SQL server that was talking to a front-end web service that was facing the public. And I said, I'm going to do exactly what I know needs to be done. And that is, I give it least privilege. I ran that SQL server under a very specific account, and the only thing that that account could access were just the things that it needed for SQL Server. It's a concept called least privilege. And I did talk about it briefly. But I'm going to give you an example because this is exactly what happens when you don't implement things like least privilege. In least privilege, you do not give any more access than you absolutely positively need. So if you're building using the AI to talk to something in a SQL database, it's going to probably assume, because I've seen this pattern over and over again, that it's an admin account and full access to it, because that's what you want for a web-facing app. No, that is exactly what you don't want for a web-facing app. What you want for a web-facing app is a lockdown account that can access only the tables that are necessary to do the function it's designed to do. Why? Because if somebody finds a hole, they will get everything. Because, hey, I just turned security off. Do you lock your front door? Do you lock your back door? Do you lock your car? No. Anybody live in a place where they lock the doors? One person. The rest of you are in tents in the park. You don't have to lock your tent in the park. Well, you can try, but it's not very useful. My parents actually live in a place where they don't lock their house. They leave their keys in the car. They do exist. They have a different threat model. Their threat model is so far away from anyone else. The threat model is not that they're going to have someone steal their car. The threat model is they won't be able to find their car keys in an emergency. So the risk of these two things, they just leave it in the car. Because nobody's going to steal the car. This is I'm just going to leave the keys in the car because nobody's going to steal it. Except that now what we're doing is we're parking it on a downtown east side street. How long do you think that car is going to be there? Nice Ferrari you got there. Each of these is a failure. The cloud is very powerful, but it requires that you build the guardrails on it. And don't count on the AI to do that. They can do it if you direct them and focus them on a specific task. But the moment that the context switches or it loses and it's done something else, it forgets, it's back there and it's building code that says, oh, well, of course I'm going to have admin access to everything. Of course I'm going to turn off all the security. Of course I'm going to bypass every protection you put in there. to minimize the PII impact. I mean, I can have these conversations. I do have these conversations with Claude where I say, don't label your data with labels that are meaningful to someone who can get it from a third-party service. I don't trust third-party services. Do you trust Microsoft, Amazon, Google? Good. And yet, ChatGPT, Gemini, Claude, they've all been trained on examples that do trust them. They leave the keys in the car. So let's start talking about the network side of things today. How many of you know anything about networks? How many of you can use the UBC Wi-Fi? Well, I mean, for some value of use, because it's not the most reliable Wi-Fi service on the planet. Everything in the cloud is in the network. Everything you talk to is through the network. It defines what you have access to, what you can and cannot do. So let's talk about these things. Anybody know what a VPC is? Because there's a video on it that no one watched. Look it up. There's a video on it. All right, I'll give you the name at some point. Anybody know what a subnet is? Okay, that's a good thing to not know too. What is the purpose of these things that you don't know about? Isolation. Why do we isolate things? Well, because you don't want to be Capital One. You don't want to have somebody steal 100 million applications for credit cards. What do people put in their applications for credit cards? Oh, I don't know, maybe personally identifiable information so that they can figure out whether or not they should give you a credit card? Probably not the best thing to just simply, like, leave in the car with keys in it. Security groups, maybe you can actually figure that out. What do you think a security group is? Groupies who get together and talk about security or something? The problem in any kind of large organization is that we need to have a way of saying, these 150,000 people have access to this resource, but not actually have to list all 150,000. So what we often do is we create a group, and that group is then an identity that we attach to the individual user who's a member of that group. So if I say, all of the people in 436C have access to the canvas, you are in a group somewhere here at UBC that says you have access to that canvas page. I don't know what it's called. Class. The canvas classroom. NACL, well, an ACL, anybody know what an ACL is? I love how that we use terminology in this business all the time, right? If you've been in computer science for a while, you will notice that we have a tendency to like make up random words and often acronyms and pronounce them in different ways that may not necessarily be intuitively obvious and encode knowledge. And by using our own secret language, what we do is we exclude everyone else from understanding. An ACL is an access control list. People are being like little beings today, not sitting in their usual seats. Very interesting. We're a group, so. This is, now you're, okay, I got it, okay, fine. And one of the things I've noticed, I've taught all over the world, and one of the things I've noticed is that, for whatever reason, people tend to take the same seat. And what's fun is occasionally I'll have classes, I do these like 5-day lectures. Can you imagine having to listen to me for 5 days? Talking about falling asleep. I do these 5-day lectures, and like, you know, sometimes somebody would be late, so they would make it the first day, and they'd come the second day, and they would take a seat that someone else was in, and it was like a ripple. And everybody just moved seats, and then it would stop. And each day after that, people would just sit in the same exact seat. And it's not, hey, how are you? It's not cultural. because it runs across the world.
Yeah.
It's very interesting. It's like this little, it's like this little territorial nesting kind of thing. It feels like it's much more primal than anything else. An access control list is a list of access rights that are given to a particular security entity. That could be a group, it could be an individual. It could be a service. Now when I say individual, it's not necessarily a human individual. It could be an individual service, it could be an individual component, it could be, gee, I trust Claude. Fools! Don't trust Claude. Don't trust anything. I was literally just watching a video about Claude where Anthropic was apparently saying that Claude is now engaging in devious behavior. And like going, okay. Interesting. What are you people doing with these things? Because Claude's always been the nice model. So an access control list for the network is a NACL. We create a new word so that we don't have to say access control list each time. And of course, these are almost completely inscrutable. That's my favorite part about almost anything in security, is that we end up creating systems that are really hard to understand, because if we told you why they're failing, you might use that to exploit and break in. So all we're going to do is turn every error into 404. Does anybody know what a 404 error is? Have you ever used the internet? Ever gone to a website? Ever seen a page not found error? That's 404. Not found. See, they used to have 401, unauthorized access. Access denied, basically. And 404. And then what happened was they figured out that people could figure out what was behind there depending on whether they got a 401 or a 404, so you could only return a single error. You could always return 401 or always return 404. If you're really tricky, you just simply randomize it. That, I think, would actually be harder for people to detect. So you have to understand a lot if you're going to try and lock down your network. Now, you can use LLMs to guide you in understanding the topology here, but they have no understanding of why it's important. You can convince a single instance, this is important because, and it'll agree with you, and it will actually act on that, maybe. But then, garbage collection comes along, you get a compaction, you get a new instance, and it's completely forgotten. And now it's back to leaving the keys in the car again. So when you walk out and you find your car missing, you can blame Gemini. Anybody know what DNS means? Sorry? Domain name server. Domain name server. It actually means domain name system, but that's pretty close. So the domain name system was invented a long time ago on a planet far, far away, when someone said, hey, wouldn't it be really cool if we could actually connect to a computer by something other than its IP address? Actually, it probably said network address because it probably was pre-IP. I mean, we only had 5 computers. You just had a little slip of paper with the numbers on them. That's 23, that's 37, that's 19, and that's 86. There you go. Done. But then it got more complicated, and then we said, well, how are we going to actually translate some sort of semantically meaningful name into an actual network address? And they created this thing called the domain name service. In the domain name service, we take a semantically meaningful name. It doesn't have to have a semantic meaning. We take a textual name and we convert it. The name itself has structure. The rightmost part of that is what level is in control of this name. And we started off with COM for commercial enterprises, EDU for educational institutions, and Gov. for government. And there have been a couple of others along the way, but essentially those were the big three for quite some time. And as more and more people started using the internet, they then had to actually create additional high-level name domains. They're literally called top-level domains, TLDs, because you couldn't say top-level domain. You've got to put a new word in there to confuse people. So we have TLDs. TLDs can be things like .ca. What does .ca mean? Anybody know? That's a hard one. Yeah! It turns out there's like this whole group of people who sit around and come up with 2-character identifiers for every country in the world. Have you seen the .io prefix? It's some little tiny country in the South Pacific. And one of their significant sources of revenue are the .io names. Believe it or not. Oh yeah. And now .ai. I don't even remember who owns .ai, but somebody owns .ai. So all the 2-character prefix or suffix names are country identifiers. And then somebody pays money to the registrar, because the way you register a domain name is you go to whoever's controlling that top-level domain, and then you talk to them and you say, "Hi, I want to buy this name. I want to buy CPSC 436c.io." And you pay money to someone, the registrar, who then in turn gives you the right to use that particular name. And this is the best part of rent seeking there actually is, because essentially they do nothing for this other than manage a little tiny database. I mean, it's the kind of database you could probably keep on your MacBook and not even notice it was running. You know what's fun about all of these examples here? Every single one of them is used to keep track of you. Proxies. Proxies are ancient. Proxies are like one of the very first things that people built on the internet. A proxy, does anyone know what the English word proxy means? Someday you'll grow up and you'll actually have retirement accounts, and you'll get mails. Well, now they send mostly postcards, and then there are electronic documents for these things called proxies. And it's literally the same meaning of the word, which is you appoint someone to act on your behalf. They act as your proxy. In computer networks, what that means is you give some other computer on the network the right to act on your behalf. Proxies come in a variety of different flavors. It's kind of like quarks. Charmed and strange. Oh my gosh, I don't even remember anymore. We have forward proxies. I take a message on your behalf, I forward it to you. I take a response from you, I forward it to the other party. That's a forward proxy. A reverse proxy is I send you a message and then you send me a response, and that gets me through some sort of a firewall, gateway. When you start working with the internet, you will find that many services require a webhook. When you look at that, and when you first start learning about webhooks, you're like, I have to put a machine out on the internet so that it can actually send me messages. I wanted to monitor my Google Drive, and my Dropbox, and my this is part of my research, OneDrive, iCloud, Google Drive, Dropbox. And iCloud, I just have to do the old-fashioned way, which is periodically poll and check and see if anything's changed. It's iCloud. But Google Drive, OneDrive, and Dropbox, they all have webhook callbacks. And what that means is I can monitor when something changes automatically because it calls a public-facing IP address. Okay, so do I have to stand up a web server someplace on the internet? Turns out you don't. What you can actually do is you can go to a company like Ngrok, and you can say, yo, I want you to put a port somewhere on the internet that I can then wire in and Google and Dropbox and OneDrive can call me back and tell me about things that I might want to actually do something with. ngrok is now a reverse proxy server. It is standing out on the network, listening to things that come in and forwarding them to you. But you're registering it with Google, Microsoft, whoever, so that you can get those callbacks. Residential proxies are like a cat's meow. If you start doing any kind of web scraping, you will very quickly learn that what happens is you get limited. You get locked. Let's suppose you work for WestJet, and you decide you want to scrape Air Canada's website for ticket prices. What somebody at Air Canada is going to notice is we're getting an awful lot of traffic from this IP address range. Let's go see who owns it. Oh, gee, look, it belongs to WestJet. What we'll do, we'll just simply rate control it or block it. Because they're scraping our website for our pricing data. So some clever person said, no, what we really need to do is just get everybody on the internet at home to give us a little slice of their bandwidth so we can send packets from wherever we want in a pattern that can't be clearly identified, so that we can then bundle this as a service and allow people to scrape the internet. Literally, the price differential between a data center proxy, which is essentially what WestJet looks like, and a residential proxy is 6x. If you can make 6 times the money selling one product versus another product, you're going to work really hard to make sure you got plentiful supply of that 6x profitable product. That's pretty cool, though. Residential proxies, they're fun. I've already talked about content distribution networks, CDNs as they're usually called. CloudFront, Cloudflare, Akamai. Every cloud provider has a CDN. How many of you have actually ever used Discord? Have you ever shared anything on Discord? You upload like a picture or a file or video or anything? So when you do that, what happens is Discord takes that file and it sticks it in a content distribution network, and it replaces it in Discord itself, in the messages, with a URI. It actually points to the thing that's in their content distribution network. And what's kind of fun about that is that Discord ended up turning into a de facto storage. It's really interesting diving into these things. And it turns out that people create de facto storage servers all the time. Can you think of anything bad that might happen if you allowed people to just upload anything they want to your website or to your service so they can share it with other people? How many of you have ever actually heard of, X? What is X well known for?
Social media.
Social media. Boy, there's a nice vague term. What kind of social media? I mean, besides watching Elon Musk.
Text-based.
Text-based, okay. So in fact, Twitter started because it wanted to limit the size of a message to the number of bytes that correspond to a single text message. Anything else? Any graphics on it at all? It's interesting how people get very quiet about what they actually don't look at on X, because I know for a fact that the internet itself was built on porn. It's not a secret, and I can hear people, I can see people like squirming going, well, I'm not really going to say that it's, it's got porn infested all over it, and the answer is yes, it does. because one of the big drivers for the internet has always been the availability of certain kinds of materials which, let's see, how was it described by someone? Undesirable materials. And you know what the problem with that is? It's not undesirable materials to some. Some of the materials that get posted there are pretty gruesome. And guess what? Every single cloud provider has a service to look for those things. And at the bottom of that particular pipeline, it is a very complicated pipeline. I could give you an entire lecture just on the complexities of the content filtering pipeline. At the very bottom end of that are gig workers, usually in very low wage economies, who are asked to look at things that leave them with PTSD. Humans are really fucked up. I wish I didn't have to say that, but they really are. And I don't really think anything of it, because seriously, like 25 years ago when I was giving a lecture might be 30 years ago now, good Lord, where is time going? Many years ago, when I was giving a lecture in Research Triangle Park, which is it's in North Carolina, I was working with a company. Your battery's running low. My battery's on, isn't it? Come on. We're back. Let's see how the recording is doing, though. Well, it did something. We'll find out. Virtual private clouds can be constructed from, get this, from public cloud services that are then connected to your private cloud services through a virtual private network. A virtual private network is just a hack that creates an encrypted channel between your machine and the machines inside of the cloud service. The key point here is they're inside the cloud service, but only you can access them unless you turn on access to them. So you can put holes in your network. You can allow people to access your network. Network level tracking is really interesting because the browser actually can't stop that. There's a whole mechanism around watching what you are in turn watching on the internet. How many of you have ever used a web browser? I'm asking questions that are really easy, so great, excellent. How many of you think you're being tracked? How many of you know you're being tracked? How many of you question the sanity of anyone who would track you because it's not very interesting? But they do it anyway. Why do they do it? I'm patient, I can wait. Why do they do it? Why do they track you? And what do they do with the data? There we go. We're getting closer. So why are they really doing it? Last week, how many of you have investments in the stock market? Did you get hit by the $800 billion drop in valuations? He's like, oh yeah, he's day trading back there. He's not actually doing any CS work. He's got, he's got his whole he's got his whole website set up there in front of him, and he's looking at this thing, and he's doing dynamic portfolio construction, and he's back testing things. Do you know what back testing is?
It's like testing on old data.
Yeah. So you build an algorithm, and then you go back and see how it would have done on older data. And that's because it doesn't cost you anything to do that, and usually is a pretty good indicator of what it might do moving forward. The more data you have, the more likely that is. The less data you have, the more volatile your algorithm is. Yo.
How does private relay work?
How does private relay?
Yeah,
In terms of?
like hides all your data from like your IP address and everything is concealed.
Right, but it's going over some tunnel. So what we're doing is we're tunneling. So they can't see what's going on inside of the tunnel, but you have to be really careful because a lot of times things leak. So what did I mention? I'm going to get to it. I'm actually going to get to it, otherwise I'll never finish this lecture. The virtual private cloud, public subnet, private subnet, the point. You get isolation as a security decision. It's not part of some organizational convenience. Anything in your private subnet has no direct internet access. Or more precisely, often you can go out, but you can't come in. If you want a really strong environment, that's more like a sandbox, where nothing comes in, nothing goes out. Or only limited things come in and nothing goes out. Because you can't exfiltrate data easily if you can only have things come in. Now the problem with that only have things come in is that you have to send something out to request something to come in. So that's why I was hedging there. I'm going, yeah, but that's where you get into the reverse proxy servers. And suddenly what's happening is your request to go out is actually a secret message that contains the data you're trying to exfiltrate. People do this. It really happens. So Capital One's case, their WAF service sat inside of a subnet, but that subnet then in turn had access to an internal metadata service and all of those S3 buckets, the ones that they basically put no protection on, or more precisely, the ones that someone could access from this subnet and gave complete access, root access. Bad. Security groups, network access controls. So we have security groups that have instance level They are stateful. They can be used for doing things like denying certain kinds or all kinds of inbound traffic. You can have rules that are, so the default is don't allow anything, and then you have permissive rules. That's a whitelist model. And that's generally the preferred way of doing it. Only allow access from the things that you trust. If you start setting up SSH servers, one of the things you can do with your SSH server is say, only accept inbound connections from places I know. Because if you don't do that, I guarantee you, someone will have mapped that there's an SSH server there, and they will be pinging you and trying to get in there and trying to attack you. How many of you know what SSH is? Secure Shell is what it stands for. Secure Shell is a way of connecting across the internet to essentially some sort of bash-like shell thing. It doesn't have to be bash, it could be PowerShell if you really want, or Warn Shell, or Corn Shell, or any of them. But they all work exactly the same way, which is we have a server that accepts an inbound connection on some port, and there's an authentication mechanism that allows you to, I don't know, send a username and password. That's a really bad idea. You should never actually use a username password based SSH. It's really not the right way to do it. It's much better to use public key. What is a public key? Anybody know? Do you really get a sense of how wide the surface area is of knowledge that you need in order to work with the cloud? This is why I actually don't spend a huge amount of time trying to talk about all these things. Because even this lecture, you're probably going to get to the end and you're going to go, talk about so much, well, what the heck? This is why, no matter what I do here, you're going to always have to be learning additional things. That's why I encourage you to use things like AI, because it does know. If you start asking it these questions, how do I set up an SSH server? It has the directions, and they'll probably work. Network access controls, on the other hand, are accesses to particular parts of the network. And so these two things create different types of protection zones. But even this wasn't enough, because Capital One's IAM, that's Identity and Access Management, IAM, that one I talked about before, was over-permissioned. We left the keys in the car. That was fine when nobody was around to see the car. But when you leave your brand new Ferrari in the downtown east side with the keys in it, don't be surprised when it's gone 2 weeks later. They left theirs open for 3 months. Has anybody in here ever heard of Gidge networks? This is a Chinese networking company. One of their primary customers is the Chinese government, who maintains very strong content filtering mechanisms for the Chinese public. And they left a hole in their own network so wide that people pulled out, it was like 1.5 terabytes of data that was incredibly detailed information about how everything they built worked. It was a lot of data. Maybe it was only 500 gigabytes, but it was a big enough chunk that you went out, you look at it and you go, wow, that is a lot of data. It happens all the time. Networks are always constantly being probed and being penetrated. And you have to be prepared for that. You have to think about that when you are building anything that touches the cloud. So if I build a claim in my software that says only the API gateway accepts inbound traffic from the internet, you better have a test for it. This is the reason you put that in there. If I'm going to claim something, I need to know that it's true. Now, I have a really cool story about this. I do a lot of work with LLMs. not just one or two models. I routinely will just like randomly pull a half dozen models out of OpenRouter and apply them. And Claude was just absolutely amazed. I don't know what else to describe it. It was really kind of surprised at what it saw, which was it used a model called GPT OSS 120B, which means it was a 120 billion parameter model from open source software is what it's supposed to be, but in fact it's an open AI, open source, open weight. It's not open source, it's an open weight model. So you can actually run it on your own hardware. 120B, you have to have a pretty beefy piece of hardware to run it. Not onerous, you know. If you've got, I don't know, $5,000 or $10,000 lying around and you want to buy the hardware, you can run it. And I've been doing a lot of work in evaluating the honesty of large language models, and so I had this piece of information that this GPT OSS 120B model had produced, and it was, I'll be kind, it was bullshit. And so we're testing how can you verify these things? These were actually about a code base. It claimed something about a code base that it claimed it had looked at. It had embedded the code in it. It didn't look at it. It just completely fabricated something. And the best part was, so then Claude picked a different model to actually audit the claims, literally this kind of thing. It audited the claims that GPT OSS 120B made, and then it built a response that required, that was part of the requirement, was it had to document the basis for its judgment, its audit. And so this little tiny Quen, it was a Quen 2.5 3B model. So it's a 3 billion parameter model. Tiny, right? 1/40th the size. And it nailed it. It found the exact code, it looked at it, it said, this is a complete lie, this is how I know, here's the lines, the citations and the lines, and boom! It was great. And Claude just thought this was the most amazing thing, that it spent less than, well, it spent 2 mils, so 2 1,000ths of a cent to run that Quen model, to find that. And I just thought it was kind of cool. So these kinds of CCTs are really interesting to me because these are the sorts of things that we need to use in this world where we are now using large language models that will just simply make stuff up. And you can actually defend against that. You can actually use them to defend against it their own way. Increasingly, what I'm seeing is that organizations on the cutting edge right now are telling human developers, you don't write code, you don't write tests. They are telling you, you use the AI to write the code and to write the tests. You are becoming an orchestrator. You are sitting there and they are the individual musicians and you are the conductor. Why are they doing that? I'm going to go back to my question earlier, which was, did anybody notice the $800 billion plunge in the market? And several people said, yeah, I did. It came back up. Did you see what triggered it? A single markdown file from Anthropic. $800 billion. That actually might be more than Anthropic is worth right now. That one markdown file was a set of instructions to an LLM on how to review legal contracts. And suddenly, the whole legal industry shuddered, and each shed like 20% of their value. There's an overreaction, for sure. But there's a lot of companies that are doing this, there's a lot of money in it. And I find what's most interesting is the analysis there, which says what is increasingly happening is that the things that are tedious that we've been using humans to do are no longer the things that we're asking humans to do. The other thing that I'm going to point out here, I want to find that one because I actually want to put that, that was a video that I saw, maybe it was an article, I think it was an article. that was talking about how one of the things that employers are now finding is frustrating about new graduates is that they need a lot of hand-holding. They come in and they don't know what to do unless they're asking the AI. And I know I'm sitting here and I'm pounding on this stuff over and over again, but the reason I'm telling you to stop believing anything these AI tell you is because that's the way you add value. If you sit there and just assume they're giving you the truth, you're going to be cutting and pasting. Has anybody heard of the company Valve? Boy, I'm on a rant today. Has anybody heard of the company Valve? What does Valve do?
You mean video games?
Yeah, what do they own?
Steam?
Yeah, that's the most important thing they actually are known to own. Steam. Today, literally today, a trial between Valve and a patent troll is going on, and Valve is very much looking like they're going to win this one. It's really, really interesting because part of that story is that the patent troll's own lawyers, they use fabricated citations. Not a good thing to do. Not a good thing to do. See, Valve and this guy entered into a worldwide exclusive, perpetual, non-exclusive license to every single patent that this guy owned and all of his companies. And then the company turned around and started claiming that they had that they were violating the patents, not the agreement, the patents. They were violating these patents. They started sending out letters to get more money. And Valve ignored them. And then they went to court, and Valve said, you're violating this contract. And so that's actually what Valve is suing this company for. Well, this guy is actually suing the owner of all these companies. Is all about these IP rights. But the funniest part was listening to them talk about how they actually had to go through every single citation in all of the pleadings that this guy's attorney filed with the court to verify every single one of them was right. I didn't want to break the bad news to them. They probably could have had Quen 3B do it for a few bucks. That's the world we're facing now. All right. If you're going to make a claim, back it up. If you're not sure that it's backed up, ask an LLM to go find the code. And if the code's not there, you're not backing it up. Over the weekend, I found a very interesting technique where I basically just took an LLM, well, Claude took an LLM, I took an agent, and I said, just go look at this code and tell me if you find anything interesting. It was literally that vague. And it was astonishing what it came back with. And this goes to something that I've noticed, is that a lot of times we go looking for things, but you know what happens when you look for something? You blind yourself to what's there. Looking for something means you're filtering out anything that isn't what you're looking for. DNS, the phone book with no privacy. Anybody can look you up, they can find out your IP address, and from the IP address they can figure out maybe where you are. What's equally interesting is just the act of looking things up is a whole series of calls through a series of different services, each of which returns information and collects information. It knows who you are, it knows what you're looking for. And that's marketable data. Every single step is visible. Your ISP sees those queries. The authoritative server sees those queries. Want to reduce that footprint? How many of you actually have ad blockers? You know what the most effective ad blocker is? A pie hole. What is a pie hole? It is in fact a DNS resolver that just simply watches for all of the things it knows are advertising asset download sites. And just by filtering those out, it makes everything you touch on the internet faster. Because everything loads assets from all over the place, and every single one of those leaves a footprint that says, you were there. And this kind of data allows data brokers to build an incredibly detailed, very rich model of everything you do. See, I built my research project was building this service that would actually take all sorts of information about what you're doing in the world and then relate it back to stuff that you've stored someplace that you can't remember because nobody can remember where they store anything. They don't remember the name of the file, but they do remember that that was a day they had, I don't know, a really hot day, or they had a really great sandwich, or they had just gotten back from Jamaica, or whatever. It doesn't make any difference at all. And so it was like we had this whole long conversation at one point early on in the project, which is like, wow, this is an awful lot of data to be collecting. And now I start looking and I'm going, no, it's already collected. All we're doing is just simply grabbing it and using it to help us instead of monetize for someone else, which was a really interesting insight. DNS, perfect example of this. The dark side of this is that, in fact, we can transfer information that tells us about everything in your network. There are actually DNS extensions that Google specifically wanted that allow them to retrieve information from behind the resolver. So even just doing a resolution means that it will tell them about all the devices on your internal network. I'm sure that wasn't deliberate. DNS tunneling is now used as a way of exfiltrate data through firewalls. You're literally sending a query that goes to a server that understands that that extra little tag of data that you sent along is what it wants. Oh look, we're exporting all of your API keys out through the DNS query. I'm not making this stuff up. You have to worry about these things. You have to think about them. Now hopefully, if you're using a cloud service, these are the kinds of things they're supposed to help you prevent. But then you're trading off one set of problems for another. DNS rebinding is tricking a browser where it looks like the attacker's server is in fact a local service. DNS can be used to route you to particular servers that are close to you. That's a very legitimate reason for doing that. You might block port 22, which is SSH, but you almost assuredly will allow port 53, which is DNS. So people will be able to talk and use these ports. The browser cannot stop lots and lots of things. You could block third-party cookies in your browser, but the network doesn't care. So what it will do is it will use things like CNAME lookups, which is a kind of DNS lookup. It says, I want to know what the canonical name of this thing is. DNS-based tracking, where we actually tag the fact that this is your IP address, and then we can figure out what you're looking at, completely separate from what you're doing, just simply by what you're asking your ISP for. We can build TLS fingerprinting. The way that you actually answer the HTTPS handshake provides information that becomes a unique key to identify your particular browser. Now, if you're on the other side and you're building apps for this, you need to know all of these things because you need to use those to allow you to increase your monetization in your app. Because the more that you know about your customer, the better that you can tailor the environment to them so that they get a personalized experience. And this is literally the argument for the other side. If you don't want your data leaking, that's fine, but they want it so they can actually sell you more stuff. And the way they sell you more stuff is by only delivering ads to you that have a high percentage of yielding something. Have you ever had like one of those conversations where you talk about, oh, maybe I'd like to go someplace on vacation, or I'd like to buy something, or I need something, and then the next day you're noticing that all your ads are about what it was you were talking about before, and you're going, they really are listening. Well, Google just settled a lawsuit about this. It turns out, yes, they are listening. We know they're listening. So we have forward proxies. They sit in front of the client. These are firewalls and VPNs. We have reverse proxies, which sit in front of the server. These do load balancing and content distribution. And we have residential proxies, which sits on somebody's machine at home. They may not necessarily even know what that is. And on Thursday, I'm going to dive into those more because those are something that will touch on many of the topics that I've alluded to here. So Hola Networks offers this free VPN service, and a free VPN service means that you're not paying for it, but somebody else is. And what I want you to understand is, how do they monetize that? What are they doing? How can you use that? Because frankly, there are perfectly legitimate reasons to use residential proxy services. But Hola Networks doesn't care. Holy Networks does not say, we won't send CSAM over your connection. Does anybody know what CSAM is? That one I'm going to make you go look up. I got in trouble for this one for last term because it upset some people. And I will actually provide, I need to provide that as a warning for people who might be upset by it. Because I don't want to upset people, but I am trying to be realistic here as well. So what happens is every user for this free VPN service becomes an exit node on this residential proxy service. Bandwidth was sold via Illuminati. I first learned about this because I actually worked on behalf of Illuminati in a patent dispute, which was not a patent dispute in that particular case. But so there was these two companies. One was called Illuminati, the other was called Proxy Labs, and they both competed for residential proxy server. They do other kinds of stuff as well, but residential proxies, that's their bread and butter. That's where they make most of their money. Today, Illuminati is called Bright Data, and Bright Data is in fact a web scraping service. But it was a web scraping service before when it was Illuminati. They were suing each other. Illuminati sued Tesso in Texas, East Texas court in the United States for patent infringement. Tesso brought Tesso is the company behind Oxy Labs, which is still around. And Tesso then sued Illuminati in a Lithuanian court because Tesso is a company in Lithuania, Illuminati is a company in Israel, and they were suing each other in various and sundry different jurisdictions because there's a lot of money. How many of you watched a YouTube video where somebody's been trying to hawk you a VPN? Anybody? Why would they do that? Why are they, I mean, of all the kinds of advertising I see, I would say that it's the number one most common thing I see advertised is a VPN service. Why would they hawk a VPN service to you? Exactly. They're doing it because they're making bank on it. The only reason to spend that heavily on getting people to buy something that's basically useless is in fact because the profit margin on it is really, really high. I would be surprised if the profit margin on that wasn't above 90%. Maybe they're taking 20% off of that for advertising. And anytime the product advertising is more than the product production and delivery, you know it's probably not a good product. So your IP address is now blasting out somebody else's traffic. This is how they build residential proxy services. You can build a legitimate VPN on top of a residential proxy service and pay. My favorite is that you can actually also pay for a VPN and turn into a residential proxy server anyway. Got to read the terms of service. So your IP address, somebody else's traffic, it could be ad fraud, or it could be credential stuffing, or it could be CSAM distribution. But you haven't looked that one up yet, have you? Good. It'll traumatize you. Nobody reads terms of service. We've already done that dark pattern lab. Content distribution networks. CDNs cache content at the edge close to users. This reduces latency. It reduces load on the main servers because now we've distributed it out and most of the actual downloads are coming from the edge. But that means we have to now do cache invalidation. And cache invalidation is just hard. What does it mean to invalidate a cache? Is 213 a requirement for this class? I don't even remember what the requirements are for this class. Anybody take a systems class? OS class? We cache things like crazy in OS. Why? Because everything we do ends up being an order of magnitude more expensive for each level we go. So if I need to go and grab something off a hard drives measure latencies in milliseconds. Milliseconds. SSDs, okay, now we're down into hundreds of microseconds. And then we get into DRAM, and now we're down into nanoseconds, 120 nanoseconds for DRAM. And then we get down into layer 3 cache, which is probably 60, 70. Let's see. 35, yeah, it's about 70 nanoseconds. And then we can have the L2 cache. And if you actually take a modern CPU out and you look at it, more than half of it is usually L2 cache. That's the part that makes the biggest difference. L2 cache is 35 nanoseconds, roughly. I mean, these are order of magnitude. They haven't changed a lot in a decade. And then we get into L1 cache. Well, L1 cache, that's sweet, because that is the same memory they use for registers in the CPU. That's 500 picoseconds. That's about, let's see, 12 centimeters, as measured by the amount of distance covered by light in 500 picoseconds, about 12 centimeters. Not very much. CDNs are another kind of reverse proxy that terminate the TLS. This is the interesting part. You no longer control the SSL TLS connection, the HTTPS connection. It terminates in the CDN, not in you. You have to actually give them your secrets, and they represent you. Cloudfront, Cloudflare, Akamai. I did actually name all of those earlier. Good. I'm not losing it. Well, I am, but not about that. API gateways are the front door. This is how you actually get clients to talk to your services. How many of you are far enough along in your capstone that you've already defined an API gateway? Uh-oh. Now it's the deer in the headlights look. If you're going to put one in there, you got to think about what is it doing. It's going to do request routing, authentication, rate limiting, protocol translation. It is the single point of entry that is going to be attacked. If you're going to put a CCT claim in there that says this is the only way to get through us, you better make sure that it's true. That means your attack surface is one component, but if it's not true, you have holes waiting to be exploited. So, the Capital One kill chain, you have a reverse proxy server that was misconfigured that allowed a server-side reference attack. You have a metadata service that was accessible from that proxy server's subnet, which means we didn't have network isolation. We had an IAM role that was over-provisioned. In other words, it was given too many rights for what it was actually needed to do. So we have no security group scoping. We have an S3 bucket that has no access controls on it and therefore had no defense in depth. No monitoring, so we didn't catch the exfiltration, so we had no observability, which we're going to talk about after the reading break. So we have 5 layers of failure here. Not 1, 5. All good security is multi-layered. To get this level of compromise, you have to really screw up bad. So when you're thinking about this in your capstone, what's your network boundary? What's public? What's private? Why are they public and private? What is your front door? Is there only one? Is there a back door? What DNS records exist for your project? Who can see them? Can your system be used as a conduit for somebody else's traffic? Do you really want to be carrying someone else's stuff? If law enforcement comes and looks at your logs, who could be implicated and for what? And if you think that this is hypothetical, you're wrong. Last week before last, Microsoft, somebody figured out that Microsoft had actually provided BitLocker encryption keys for someone's actual computer because the person had stored them in Microsoft's cloud. And Microsoft encourages people to do that so you don't lose access to your Windows laptop in case you lose your keys. Most people don't think that they're actually giving up control of their data when they put it in the cloud. The moment that you put it in a US provider, you are subject to US jurisdiction. And I do these kinds of exercises all the time. I said, okay, let's suppose I actually wanted to have a completely cloud-based data service where no one single country could actually get the data. And I said, okay, I will use erasure coding and I will put it in different jurisdictional control areas, and I will require at least 2 or 3 is the paranoid number, at least 3 of those have to be compromised before they can read that data. And I'm going to encrypt it, by the way. I described that to Claude, and it was like, wow, this is really good. You're not only mixing, things like doing data, doing the erasure coding to spread the data out, you're also using jurisdictional overlap to protect it. Because you're not going to find any law enforcement agency that's going to be able to get an EU warrant, a US warrant, and a Brazilian warrant at the same time. Probably not. You can design these things, and it's a lot of fun. I find it a lot of fun to do that. I mean, I sit down and design these kinds of things all the time. I'm talking about this stuff in class, and then I go home and I'm like, I wonder if, or could I do that? And then I'll go and I'll explore it. To me, it's fun. These are CCT claims. If you can't test them, you don't know the answer to them, and these really should be things you're addressing in a decent capstone. All right, biweekly check-in number 3 is up. Submitted before Thursday, not too long. I will do the same thing I did last time, which is, I didn't really report on the results last time, but I pulled them all. I did the analysis on it. I did action something, and I don't remember what it is now. And I'll do that again. So those are really helpful for me, and I very much appreciate it. This is how I try to measure what's going on there. And I don't actually look at who they come from. I actually aggregate everything, strip identifying information off of it, because frankly, I'd rather have your honest opinion. Oh, you really suck. That's fine. Great. Why do I suck? Because you're a vacuum. Great. Thanks. Thursday we're going to do dark pattern lab number 2, which is about attribution and liability. And I'm going to come back to this idea about things that can happen in the real world and who is affected that wasn't part of the decision-making process. And there you go. Tuesday swirls into the porcelain vortex. And I'll stop the recording. I'll thank everyone for coming.